All right, good morning, everyone. So we have finally finished up Unit 3, which I don't know about you guys, but seems like a very long unit. And we are officially moving on to Unit 4. So you should be looking in your packets at the 4.1 notes, and we're going to start working through all of this and kind of talking about polynomials that are just a little bit different than what we were working on in the past. So we are still kind of building on where we came from. Where we came from was the idea of quadratics, and now we're going to be kind of expanding upon that and looking at equations that have higher exponents, in short. So when looking at a polynomial function, in order for it to actually be a true function, all of the exponents and variables must be integers, and they must be greater than or equal to 0. So they can technically have an exponent of 0, but most of the time you're going to see them with an exponent of 1 or higher. And then, the idea that it's an integer means no fractions, no decimals. Each input has exactly one output, meaning that for every x that we put in, we will have exactly one y value. In other terms, this passes the vertical line test. A lot of you are familiar with the vertical line test. So in short, it's just saying in order for it to be a function, it must pass the vertical line test. And when we say input, keep in mind we are talking about the x value. For every x that I plug in, I get only one y. Sometimes there are multiple x's to a single y value. I mean, think about a parabola. But at the same time, as far as x values go, when you put one x value in, you will only get one y value out. This means that the polynomial is a function if it passes the vertical line test. So we look at the three examples down below, and we are determining if it is a polynomial function or not. A should be strictly a no. Sorry, no variables in the exponents, just added a little note there. But the first one's a no because of that 1/2. Second one, even though it has that square root of 7, it does, when you look at the exponents, only have an x to the second power, so that is a function, yes. Number 3 should be no because of that -2. And then the last one, looking at that, you have the exponent of 4 and 3, which is all good, so yes, that is a function. Now, when talking about polynomials, like I mentioned before, we are going to get into equations that have higher exponents, such as the last one over here, where the exponent was 4. We're going to learn how to graph. We're going to learn how to factor equations that have higher exponents. So at this point, we've pretty much only worked with x squared and all things x squared. We've factored x squareds, we've graphed x squares, and now we're going to see some other ones. To understand graphing of these other ones, you need to understand two key words, one being leading coefficient and the other one being a degree. So first of all, the leading coefficient. The leading coefficient is the number in front, and it is the one with the highest exponent. Now, typically, these equations should be written in standard form, which means they are going from the highest exponent to the lowest exponent. So if it is in the proper order, this is the number in front of the variable at the very, very front. That is going to be key. We're going to talk about how leading coefficients become important later and their role in the graphing process. The next one is the degree of the polynomial function, which in short is the largest exponent. So if you look at D up top here, the degree would be 4, and the leading coefficient would be -1. Last part there is that standard form I mentioned before is it should be in descending order, meaning from highest exponent to lowest exponent, going from the left to the right. So let's talk about some of the most common polynomials out there. First thing is we kind of break down their degrees. So these are kind of the most common degrees that you're going to see. I'm not saying that the degrees don't go above 4, but a degree of 0 through 4 are some of the most common ones. And again, there are degrees above that. Obviously, you can have to the power of 5, 6, 7, but these are the most common. As far as what type they are, the first one we actually just call that a constant because if it has a degree of 0, that means there is no variable, it's just constant. Having a degree of 1 would ultimately be a y equals mx plus b situation. Having a degree of 2 would mean having an x squared, henceforth a quadratic. That's where we just came from. And the last two, to the power of 3 and to the power of 4, would be cubic and quartic. Some examples of those, you can kind of throw down whatever examples that you want. I'm just going to kind of click through these. If you need to, you can pause the video and kind of get each of those down. But they show you just kind of that idea of the highest exponent being that degree and matching up. So down below, you got 4 examples. I'm going to let you kind of pause the video in a second here and kind of work through these examples on your own. But ultimately, what you're supposed to do here is first determine, is it a polynomial function, yes or no? So similar to what we did up top with the A, B, C, and D, go through all 4 of these and say yes, no, as far as is it a polynomial. Those are not the answers for the record. But once you go through that, the no's, the ones you said no for, that's it. You just said no, it's not a polynomial, you're done. The ones that you say yes for, I want you to rewrite it in standard form if it's not already in standard form. Keep in mind standard form is highest exponent to smallest exponent. At quick glance, I'm not saying they are or are not polynomial functions, but B is definitely not in standard form because those exponents are in the wrong order. Over here, that's, that is what it is. And this one's totally fine. It's in standard form. So standard form doesn't take long. It's just highest exponent, smallest exponent. Then I also want you to say the degree. Remember, the degree is the highest exponent in the entire equation. You should also state the leading coefficient. The leading coefficient should be obvious once you have it in standard form. And then the type would come from up here. What category does it fit from up here? So now's your chance. Pause the video. Go ahead, do all of those. And then as soon as you unpause the video, we'll get some answers in here. So you should have paused the video. You should have done these. So I'm going to really quick kind of put all these up here. Oops, too far. There we go. And go through them. So C was no. D was no. So that was done. Those 2 are done. Over here, these were both your yeses. So yes, they are polynomials. Putting them in standard form, the first one was already in standard form. And then down here, B, putting it in standard form would be that square root of 2x to the 4th, kind of right about here. You're seeing the degree to be 3 for A and the degree to be 4 for B. Up here with A, because the degree is 3, look up top, that's cubic. And then this degree was 4, so that would be quartic. And then the leading coefficient, now that it's in order, that would be the -2. And then this one, look at it in order, standard form, should be the square root of 2. So we're going to move on now and kind of talk about, I mentioned earlier about how the leading coefficient and the degree can kind of help us in our graphing process. So quickly coming across here, just trying to see something. I wish I knew how long this video was, but I don't. So we're just going to keep powering through. Actually, can I see it? Nope, still can't see it. Sorry, I was just trying to see if I could see the time, but I don't know how to do that on the still part. So anyways, so going through what is going on in the X. So we're going to be talking about this thing called the end behavior. The end behavior basically means when you look at the graph, what is happening, you know how like at the end of a graph, there's like that little arch that points up, or like the arrow that points up or points down. What we're going to be doing is talking about what's happening at those arrows. What's happening at the very end of the graph. Now, obviously the graphs go on forever and ever, but the point is kind of saying like, when it's going on forever and ever, is it going up forever and ever, or is it going down forever and ever? So what we typically say is what is going on as x approaches infinity. I would personally put a little note on there that is on the right-hand side. So when x goes to infinity, we're talking about the right-hand side. So looking at the graph here, as x moves to infinity, you're going to the right-hand side. As x goes to negative infinity, you're going to the left-hand side. From there, a lot of this can be determined, as I said, the degree and the leading coefficients. So we'll talk about some summarizing here in just a second, but let's get some points across. So the first category here, we have even exponents, odd exponents. Rule of thumb, and again, put this in your notes because I have it written in mine. Even is when the end behaviors go in the same direction. So again, even is when the end behaviors go in the same direction. So if one side's going up, the other side goes up. If one side goes down, the other side goes down. Odd is for opposite. So if one side goes up, the other side goes down. If one side goes down, the other side goes up. So the first thing you always do is you determine the degree. Is the degree even or odd? So previous, backtracking here a little bit, you would look here and you'd say, okay, the degree is even, that's going to be the same direction. The degree is odd, that's going to be opposite directions. Then you get into the leading coefficient. And the leading coefficient really, really is probably the most important one, because ultimately that decides what's happening on the right-hand side. So if you have a positive leading coefficient, then your right-hand side, here's an example, your right-hand side goes up. So look at that right-hand side going up. It's even, so the other side does the same, up and up. And I genuinely do not care what the graph looks like. I'm just focused on what's happening at the ends right here. Now, if it's negative, you can probably guess. Negative would be kind of the opposite. Let me jump to this one. So here's a negative, in which, look on the right-hand side, it's going down. Of course, the exponent's even, so they are going to be going the same, but our focus is on the right-hand side going down. Now, as I clicked through this, you might have noticed these notations down below. This is the algebraic way of saying up and down. So basically saying as x goes to infinity, remember up here I told you that's the right-hand side. So basically as x goes to the right, f of x, which is a fancy way of saying y is going up, so we say infinity. So infinity is the sign for up, negative infinity is the sign for down. When I look at the second notation, reading this in proper English, this would go as x goes to negative infinity, which simply means the left-hand side, the y value is also going up to infinity. If you look over here, the x part of it never really changes. It's always like x going to infinity, x negative infinity, x infinity, x negative infinity. Your focus is more on what's happening to the y values. Are they going up, like over here, infinity, infinity, or are they going down, negative infinity, negative infinity? Now, the odds are pretty much the same concept. It's just that these ones have the opposite directions on them. So I'm just throwing these up there in case you need to pause the video. But what you're seeing over here is, again, if your leading coefficient is positive, so same as this one, leading coefficient is positive, your right side should be going up. If your leading coefficient is negative, your right side is going down. But because the degree is odd, they're opposites. So you always kind of determine the right-hand side first, and then you go left-hand side. So here's some rules that I kind of personally think are important to kind of have written down. I know there's not really space on your paper, so find a spot if you haven't already. But just breaking down some of this language. So this idea that as x goes to infinity, that just is talking about the right-hand side. As x goes to negative infinity, that's just talking about the left-hand side. What's happening on the right? What's happening on the left? F of x, that again is the symbol for y's. So if it's going up, you're going to say positive infinity. If it's going down, you're going to say negative infinity. Some of these other parts here are just kind of what I was talking about. If it's even, that means they're going in the same direction. If they're odds, it's going in the opposite. I always think of like the O and the O, odd, opposite, kind of help me remember. Now, you cannot determine what a graph looks like or the end behaviors on just the degrees alone, because the degree just simply says, hey, are they going in the same direction or opposite direction? It doesn't really tell you anything about up or down. So that's when the leading coefficient comes important. And basically, if the leading coefficient is positive, the right side goes up. If the leading coefficient is negative, the right side goes down. So you kind of look at the leading coefficient first, and then from there, you can decide, are they going the same direction or opposite directions? So right-hand side comes first, decide if it's going up or down, and then once you know whether it's going up or down, you can go from there. Now, if you notice, all of this discussion can kind of be happening without even having the graph available to us. So for this last slide here, I actually want you to just pause the video, try out the idea of leading coefficient, being positive or negative, degree being even or odd. Pause the video and then come back and check out the answers and see how you did. So I'm just going to throw the answers up here. Oop, too far. And there's your answers for all of them. So again, that idea of leading coefficient going up or down for the right-hand side, and degree being even or odd as far as same or opposite. And that's everything for today.